Okay, so here's the second problem in the proof game. And I'm going to do a side-by-side proof. It will take a little bit less space. But the basic idea is this. They want you to show, so they tell you that angle 2 and angle 1 are the same. So I'm going to write that in red. They also tell you that angle 4 and angle 5 are the same. So those are given things to you. Okay, so there they are there. And what they want you to show, and I'll do that in blue again, they want you to show that KL is the same as LM. So we want to try to get to the blue thing. So we're going to have to use CPCTC again, and we're going to have to get some congruent triangles. So let's talk about that right now. And one of the things I noticed is that this side is shared by both triangles. Okay? And so that is going to be very important because it's going to give us a free side that's in both triangles. So let's do some work here now, and let's figure out some more information. So we're going to write down our given information, and the stuff that I originally put in red, I guess I should go and draw that thing in green. I noticed this, and I'll deal with that later. Let's write down what we know in there first of all. We know angle 1 is congruent to angle 2. We also knew angle 4 is congruent to angle 5 because it was given to us. So that's our first statement. Okay. Now some of you are saying, well, okay, let's write down some other stuff. Now this is our first A in the problem, and we already see the side that's in green there, that squiggle in green. So let's put that in green. Step 2 is that JL is congruent to itself, and that's reflexive property. Okay, that's the reflexive property of segment congruence, but I'm just going to write reflexive property, and that actually gives us our first S. So I'm going to put a little S right here. So we've got an A and an S, and the A is touching the S. Okay, so it could be ASA or it could be SAS, but I can't really use the blue ones because I don't know that they're the same yet. But some of you are like screaming that there's another angle pair that we know about, and so let's do that right now. I'll just point that out. That angle 1 and angle 3 have to be the same because they're vertical angles. You see these vertical angles becoming very popular, so I'm going to write that down. 3. Angle 1 is congruent to angle 3. Vertical angles. Okay? And that doesn't do anything as far as giving us a letter, but it leads to, well, if 1 is the same as 2, look at step 1. If 1 is the same as 2, 1 is the same as 2, and 1 is the same as 3, then it must be that 2 is the same as 3. So angle 2 is congruent to angle 3. We call that the transitive property. Okay, and now that gives us another angle pair. And when we look at it, it looks like I have a set of angles, a side, and another set of angles. So that's and the side is included or between the two sets of angles, so it looks like ASA. So I'm going to say something about ASA here now. So I know my next reason is angle, side, angle. And I just need to write down which triangles are the same. So triangle JML is congruent to triangle JKL. And that allows me then to say, with as all these are doing by CPCTC, we can now say KL, which is what they want us to prove, is congruent to ML.